The problem statement from GATE Physics 2015 reads as follows. In an inertial frame S, two events A and B take place at CTA equal to 0 and the space coordinate RA vector is 0. And the second event B is CTB equal to 0 and RB is 2y cap respectively. The times at which these events take place in a frame S prime moving with a velocity 0.6 c y cap with respect to S are given by. So two events are happening A and B in some frame, inertial frame S, and similarly same events will be happening which we denote by A prime and B prime in some other event S prime, and we need to find the time and space coordinates, in this case only the time coordinates of both these events in the moving frame. But before we try to solve this problem, let's have a quick look at some relevant concepts. There are some terms which keep coming over and over again in special theory of relativity, and it's good to visit them. So first is the inertial frame. So what are inertial frames? These are those frame of references which are either at rest, that means their velocity is 0, or their velocity is constant. This means velocity is not a function of time. So those are the inertial frames. So usually with every inertial frame there is an observer associated. For instance, let's look at this frame. We call it the S frame, or let's call it the rest frame. This means its velocity is 0. It's at rest. So there is an observer in this frame. So this person O sitting at the origin is the observer for this frame. Similarly, let's talk about another frame S prime. This frame S prime is moving at a constant velocity v with respect to the original frame S. So this is also an inertial frame because this velocity is not dependent on time. And here another observer is sitting at O prime. So what do these observers do? These observers will observe some events. So what is an event? An event is denoted, let's say some event P. This may be ball touching the floor, someone clapping their hands. So this event has some space coordinates associated, let's say x1, y1, z1, and one time coordinate, let's call it t1. The same event will be observed, may be observed by this observer O prime, and we denote it as P prime. So everything is primed in this frame. So this will be x1 prime, y1 prime, z1 prime, and finally t1 prime. Similarly, let's say there's another event Q which is x2, y2, z2, and t2, and similarly it will be denoted as x2 prime, y2 prime, z2 prime, and t2 prime. So these are two independent events P and Q which will be seen as P prime and Q prime by this observer O prime. So how are they related? I mean, is there any relation between these two events? Yes, there is. There is an entity called space-time interval which remains invariant across different inertial frames. This means if you calculate this entity delta S for this frame, this will be equal to the entity delta S prime for this frame. So what is this entity? What is this mathematical entity delta S? This can be given by this formula. So this is called space-time interval. We call the first term as time interval. And we call this term as the space interval. Note the space interval is very close to what we are used to seeing as the distance, right? So this is what we call the space interval. Hence the difference of time interval with space interval is the square root of that will be the space-time intervals. Note here the square is here. So that's what space-time interval is. The key thing to note is that the space-time interval remains invariant across different inertial frames. So that is the key thing to note here. Right, just and using this concept we can transform from, let's say, we can get the coordinates of P prime if we know the coordinates of prime, which we call the transformation, and we can obtain it like this. So again, this is the S frame, your rest frame. This is the S prime frame, your moving frame. So let's say if your V is not relativistic, this means V is less than C, then we are habitual of seeing this kind of transformation, right? Time does not change, and x prime will be simply x minus vt. So there is a particle P here with x coordinates x, y, z, and t. Similarly, this event will be P prime, x prime, y prime, z prime, and t prime. We have seen that, right? So, but what happens when we get to very close to the speed of light, when we approach is c, like 0.1 c, 0.2 c, then we can use this concept of space-time interval. We have seen that it remains invariant, and what we can obtain is what is called the Lorentz transformation. So here relativistic means v is approximately c, 0.1 c, 0.2 c, very close to c. So we cannot use the Galilean transformation, that is we cannot get simply by this formula. So using the concept of space-time interval invariance, we can obtain the coordinates t prime and x prime if coordinates t and x are known, where gamma is an entity which is given by this formula. So this is a very straightforward derivation. You can refer to textbooks, but this is the thing that's very commonly used. Right, note that y and z did not change because the movement of this s prime frame was only in the positive x direction. Now, coming back to the problem, before we start solving this problem, it's good to have some pre-checks. So what are they? We'll check whether the frames are inertial or not. So we are given some frame S and another frame S prime. So we know S is inertial. The question says S is inertial. So S is inertial. That's good. What about S prime? So we'll see that there's another frame S prime moving with velocity. Note the velocity is constant. So this means S prime is also inertial. S prime is because it's moving at a constant velocity, right? So what is the for moving frame, the second p-check we do for the moving frame, what is the speed and direction? So we notice that the question says the speed is 0.6 c y cap. So I'm assuming this direction to be y. So this frame S prime is moving in this direction at speed of 0.6 c and direction is y or y cap, you can say that. The number of dimensions, the problem only talks about in, so you can see there are only y coordinates here, so we can simply ignore x and z components, and we can say it's only a one dimensional problem, and that dimension is y. Note the dimension is y, right? I have just reproduced the previous system here. So this is our frame S. We can assume it to be at rest, while the second frame, the moving frame S prime, is moving at some constant velocity v, you can see here, at which is equal to 0.6 c, and the two events A and B are happening at 0 y cap and 0. This is the time coordinate, and again for B it's 2 y cap and 0. Similarly, the same events will be happening at some different at prime here. So it's A prime, you can see, and similarly B prime here, and we are required to find the time coordinates of A and B in the S prime frame, that is TA prime and TB prime. It's a fairly straightforward problem again, because we have already established the frames are inertial, so we can simply use the Lorentz transformation. So first I'll obtain is what I obtain is TA prime. So TA prime would be gamma TA minus V YA over c square. Note everything is happening in y in this case, and x and z remain unchanged, while only t prime and y prime will be changed. So what I'll do is let's keep gamma as it is. The value of ta, that is the time coordinate of event A in frame S, which is 0. So I'll put 0 here, minus v times YA, which is again 0, over c square. So this will come out to be 0 minus 0. So this will come out to be 0. So the timestamp for TA prime is coming out to be 0. Now let's evaluate TB prime. So it will be gamma TB minus V YB over c squared. So gamma, so the value of TB, again timestamp here is 0 for event B in frame S, which is denoted by TB. So this will be 0 minus V times the value of YB, the space coordinate is 2 in this case. So V times 2 over c squared, right? So this will come out to be, if we do this will come out to be minus 2v gamma over c squared. Now we know the value of v, but we first should evaluate the value of gamma. So we know the gamma is written here, so I can simply say gamma would be 1 minus the value of v is 0.6 c, so 0.6 square c square over c square. This gets cancelled. This will be 1 minus 0.36. So this will be 1 minus 0.64. 1 minus 0.36 is 0.64. This will be 1 over 0.8. Okay, so we have obtained the value of gamma to be 1 over 0.8. This will be, I think, yeah, 5 by 4. So I'll put all these values here. This will be minus 2 times the value of V is 0.6c, 0.6c times the value of gamma is 5 by 4, 5 by 4, and c square remains. So this gets cancelled. So this is coming out to be 5 into 2, 5 into 2 would be 10. This will be 6 by 4. So this will be minus 3 by 2c. So Ta prime is coming out to be 0. So I'll write it here. Ta prime is coming out to be 0, while Tb prime is coming out to be minus 3 over 2c. Right. I'll just multiply both sides by c. So this will be c Ta prime is equal to 0. C into 0 is 0. And I'll multiply by c here. So c Tb prime would be minus 3 by 2. So these are the coordinates that we have obtained. The c Ta prime is 0. It's 0 in all the 4 options, but c Tb prime should be minus 3 by 2. So yeah, so it's only in option A. This is only MCQ with only one correct answer, and A is the correct option here. Thank you for listening.